Google Gemma 4 is out and it's making some noise. What if you could run an AI model that beats systems 20 times of its size? And you can run it on your laptop and completely offline. That's exactly what Gemma does. And released it in April 2. Google DeepMind's most powerful open-weight model changes everything what is possible on consumer hardware. Stay with me because on the end of the video you will understand why a lot more is possible with Gemma. So, what exactly is Gemma 4? It's fourth generation of Google open-weight AI models family. I have used it a lot, Gemma 3, in a lot of projects. And I'm a big fan of it because it's one of the best all-rounder for generic tasks. To see how successful this family is, the numbers speak by itself. 400 million downloads of the Gemma family and 100,000 of community variants that are ready to get used. And the support of 140 and more languages is one of the reasons that Gemma is very loved by people. Okay, now let's see the model sizes that we have on Gemma 4. We see some changes in compared to Gemma 3. Some models getting bigger, but it's a reason about what's happening here. First we see the two smaller models, the A2B and A4B. These are the edge models that are supposed to run on smaller devices like phone and have some features like audio and video embedded. They don't need a lot of RAM to run. It's the first model needs only 1.5 gigabit of RAM and runs very smooth. I tested it on the smartphone, so you can run locally a capable AI model, and it runs it and responds very fast. Then we have the 26 billion model. This is mixture of experts model, and its architecture is a game changer. Finally, we have the 31 billion model. This is the big one, and which is currently sits on the top of Gemma. Okay, let's take a look to the features that we got here with Gemma 4. One and the most important is the built-in thinking mode. So the model is a lot more capable of more. The second and important one is the native audio support. The model can now listen to the audio and export the text. And the important one is that it can understand what about we are talking. And this feature is embedded on the two smaller models, the A2B and the A4B. So we can run it on the device, and the audio that comes, maybe we speak to the agent, it can automatically read the audio and understand it. So it don't needs to get out of the phone. We don't have a delay of the network. It is gonna, all this stuff is read it immediately by Gemma 4. So this is an important feature. Advanced vision is adds a lot of stuff too. It handles OCR very fast. It understands charts that it sees, handwriting or video frames. So it's very helpful. And we have a lot of tasks where we can use it to analyze something that we read or data that we feed the agent. It uses its OCR and the charts and understands exactly what there is. And robotics, because it can analyze objects, video frames. And And of course, we have the agentic and function calling. This was not possible only with workarounds in Gemma 3. Here we have it natively, and the AI, Gemma 4, can select what tool is needed to get the task done. As we need some tools that need to be called, Gemma 4 knows immediately what tool it needs, and that gives us a lot of more action options and capabilities. This reminds a little in Claude Code that using a lot of external tools. So Gemma gets upgraded in this section too. And of course, a new one is the Apache 2.0 license. So this is more important for businesses that are gonna use Gemma for their work. They can use it without problems because the Apache license is a lot more open. It don't need fees, and they can use it free. And of course, we have a new architecture here. We're gonna see it later in more details because the architecture is the most important for the performance of the model. And here we see a comparison table, Gemma 3 versus Gemma 4. We see the model sizes that we mentioned that are a little different. That was 1, 4 billion, 12, and 25 billion in the Gemma 3. And now we have the 2, 4, 26, and 31. We have the change in the architecture, the context window about we talked. It's a lot larger. We have the double in the bigger models, and we have the capabilities of audio and video that we didn't. We have the native support of the audio, the thinking mode, and all the functions, and all we talked about. And here we have a more interesting point, the benchmarks. Let's see how Gemma 4 performs. Okay, on the first one, on the MMLU, the standard knowledge benchmark, Gemma 4 scores with 88.2 versus Gemma 3 on 79.4. So we have improvement here. On the human level for coding, it jumps from 66 to 82%. And in math, we have an improvement too, from 65 to 81. So it's a very big improvement. But how is it possible? And the big improvement is in the long context. Gemma 3 claimed that it can handle 128,000 tokens, but in reality, this wasn't not right. It handled 13.5% of the context in the most tests, and Gemma 4 can handle 66.4. This is an amazing increase of context, and this opens a lot of more capabilities to use it in agents and code where long context is needed. And in competitive programming, Gemma 3 had an error of 110, which is beginner level, and Gemma 4, 31 billion, hits 2150. That's in the level of expert programmers. And this will be very interesting if we test it in coding. In short, we see the length, the context length comparison. The Gemma 3 had 128, but just on the papers, it can handle the 13.5% of that, and we have here 5 times more increase in Gemma 4, and in the large models, the 258K. That is the big improvement that we talked about earlier. Here we see in what devices Gemma can run, starting from the small models. It can run on flagship phones, and the Raspberry Pi, and the NVIDIA Jetson, of course. This is a very good option to run at 24 hours because it uses not much energy to run. And the consumer GPUs, the RTX 3060 with 2 gigs of RAM, or the 4090 with 24 gigabits of RAM. There we can run a lot strong models like the 26. And then workstation server with much more expensive hardware, we can run the bigger models. Here I want to mention TurboQuant because it's, in my opinion, one of the most significant research of AI during this year. At the same time, Google was working on Gemma. It was researching on a new technology, TurboQuant, that will play a significant role in AI models. When TurboQuant was announced, the prices of RAM dropped because the data centers will not need so much. The same happened to the GPUs, and it's not used at this time. We're gonna see it in 1 or 2 months in AI models. But what exactly is TurboQuant? TurboQuant is a compression algorithm, but it's not used like a quantization that shrinks the model weights and makes the model weaker and smaller. With TurboQuant, it shrinks the KV cache. That is after the model has the tokens generated, it must save it somewhere, and that is the KV cache in simple words explained. So it shrinks that by compression it, and this reduces the memory reduction 6 times, and that all without losing of power of the model. The result is a much more speed, 8 times faster in an H900, and 6 times less memory. This is why TurboQuant is a revolution in AI, and it definitely will give us the same model that we run at this time in much more speed and less memory. I just wanted to mention it here and not to make a different video about TurboQuant, and some points are included in Gemma because the time of research was the same, but it was tested on Gemma too, but we will see a version with Gemma with TurboQuant soon. We see how fast the evolving of the models is the last months. We saw Gwen 3.5, we saw Gemma, we're seeing TurboQuant, and a lot of new things are coming that are very exciting. But let's see a comparison how Gemma 4 does with other models. Here we see all the models, the Gemma 4, 21 billion, and the smaller one, the 26. If we take a look in more details, we see that if we compare it with Llama 3.570 billion, it has the same results in the MMLU tests, even a little better. The 70 billion model get a score of 86, and Gemma 26 billion get an 87.5. This is amazing for a much smaller model. And if you take a look in the RAM, then we see the Llama uses 40 gigabyte of RAM, and Gemma 4 uses only 14 gigabit of RAM. An amazing improvement. Well done, Google. Here we see Gwen 2. It's an amazing model too, and the new version, the 3.5, and it has similar score in MMLU and in the other tests too. But I need to mention here that Gwen needs a little more power to get the same results. So Gemma needs a smaller GPU to run it because of the architecture that is used. It can pick, if you see here, the active parameters can be 4 billion, and it can easily select what parameters are needed, so it don't need to run all of them like Gwen did. Should we upgrade to Gemma 4? I did it already. Any instance that was running in Gemma 3 is upgraded. We must admit that this was one of the largest generation upgrade that we ever saw. Stay tuned for more tests with Gemma. I think it's worth to dive in on its capabilities of coding and of course usage with agents, because it has long contexts, and image and charts and OCR capabilities that the model has. I'm testing it already from day one, but I always wait a little so I have a better picture and understanding of the model and its differences, so I can describe it with more accuracy. Stay tuned for the next videos.